Hello, my name is Jordan Richardson, and this is homework 1 for machine learning. In this assignment, we created 4 different regression models: KNN, OLS, Ridge, and Lasso regression models. For KNN, Ridge, and Lasso, we varied a parameter. For KNN, it was K, and for Ridge and Lasso, it was alpha. So let's start with KNN. We read in the data, we split it into feature and target, along with training and testing sets. We scale the features. We create 3 lists to store the accuracy values for mean squared error and R squared, along with the K values I want to test. And then for each K value, it fits the model and predicts on the test data. That is scaled, and then appends the accuracy for mean squared error and R squared to those lists. Then we plot both MSE and R squared versus the K value. So this allows us to see what the accuracy is at different values. I had it set up at one point to automatically pick the optimal K based on the lowest mean squared error value. And then I also have it looping through the same Ks that we tried above and printing the actuals versus the predicted. And then I've also got it adding the accuracy above each thing. So let's see what that looks like. So here's the mean squared versus K, and here's the R squared versus K. What I found is these are actually basically inverses of each other. So I probably will only use one for in the future. And something I realized after I completed the assignment is I can also run this against test, or the training data, I should say. And that will actually allow me to better identify underfitting and overfitting. And then these are the actual K values predicted versus actual. So at 1 it was 0.66. 2 is where I found the optimal. It goes all the way to 78% accuracy, or mean squared error of 16.111. And this is 74, and then it starts to basically underfit and go down as you go through the case. So that's KNN. Lasso, or let's do OLS. OLS is actually very similar, except that it does not have a parameter that you vary. So I just had to scale it and run it through and plot it, and this is what it gives back. 67%. For Ridge, we vary the alpha, and that's what that would look like. And it's in the logarithmic scale because otherwise decimal points just don't look good if you can see the Y in the top right corner barely changing. Or, well, actually, it's not right. But otherwise it'd be 0.00001 and then 1 decimal place, 1 decimal place. These are the actual alphas. I believe, yes, 162 is optimal for this. And then it begins underfitting. And lastly, we had Lasso, which actually makes it so that it does not overfit. It will reduce things to 0 to do so. Optimal was 0.00001. And then it's very slight changes until you start getting to like 110. And that's actually very inaccurate. So this is my code. This is homework 1, regression models by Jordan Richardson. For the agenda, we have the introduction, and then each of our 4 models: KNN, OLS, Ridge, and Lasso. For this project, we were to create 4 different regression models using a test and trained data set that was supplied to us. The features and target variable were indicated clearly. Our goal was to find the best parameters for our regression model and identify cases of underfitting and overfitting. My initial thoughts on this assignment was code it up was very easy. It only took me like an hour or two. But it really becomes a matter of, do I know why it behaves a certain way? How can I control that? And how can I change the model to basically fit my needs? I was able to get a decent test accuracy for each model. Let's start with the k nearest neighbor regression model first. So for this model, I was able to get something working really quickly. Then I began to tweak it so I could have it run through multiple k values instead of having to input those manually. I used both mean squared error and R squared for this assignment to find the best k value, and I also scaled my features using the standard scaler. For this model, I identified 2 to be the best k of neighbors because I was able to get 78% accuracy. I would consider 1 to be overfitting because it's not generalizing well to new data. And then 3 and moving forward would be considered underfitting because it hasn't learned the complexity of the data itself. And these are the optimal results at k equals 2. And you can see my accuracy and the mean squared error up here. And this was my worst one, which was k equals 1, which was only 0.66. If you can kind of see the difference there. Next, we have OLS regression. For this model, we were not given a parameter to alter. Instead, we were to indicate this model was a good choice for this data, period. I would say, personally, that it's not a good model for the data set. The very first model I did for this assignment was KNN, and that was able to predict with a higher accuracy rating than OLS. It would be less of a good fit than KNN, so why would I use a model that does worse? I was able to get 0.67 though percent R squared, and someone unfamiliar with KNN, or if their data doesn't fit exactly as well with KNN, this may be a great option. Next, we have ridge regression. For this model, I was able to pull quite a bit from the KNN model, change some variables, model names, and basically was able to run predictions pretty quickly. I also used mean squared error and R squared for this model, and I ran through this with a variety of alphas and found the best to be 162. For this specific model, I identified 162 to be the best alpha. I had to do alpha on a logarithmic scale because a bunch of decimal x values would basically throw all of the points together really close. 162 gave me a mean squared error of 23.38 and an R squared of 0.68, which is better than OLS, but still isn't compared to the highest of KNN. For this specific model, I found that the model was likely overfitting at the start, only to start to hit the sweet spot right around here. It hits the sweet spot, and then it's actually a global maximum for ridge, and at that point it begins to underfit rapidly, and this is like 10,000. But I did have points filled out throughout here, and it's just a downward slope. These are results of plotting both my actual values and predicted. You can see the percentage of accuracy up here and my alpha of 162. And I ranged all the way from 0.000001 all the way to 180 at 1 decimal place change per alpha. Next we have lasso. For this model, I was able to pull quite a bit from Ridge. Again, just change some variables, models, and run predictions as they both use alpha. For this one though, I did find the best to be 0000001 instead of 162, so it's actually on the other end of the alphas. Here you can see that the R square starts out really high and stays pretty consistent before it begins to underfit. The reason for this is lasso actually puts like a I guess damper to basically prevent the model from overfitting on the data. So these are basically the best R squared we're going to get, and then this is underfitting. 0.00001 gave me a mean squared error of 24.29, and R squared of 0.67, which is about the same as OLS. And like I said, I do not believe there was any overfitting, and it rapidly begins underfitting at 0.1, going into 1, 10, and finally 100. These are the actual results. You can see my alpha up here and the R squared of 0.67. This was assignment 1. Thank you and have a great semester.